the Microsoft Reactor here in Stockholm. If this is your first time here, I would say the Microsoft Reactor is basically an investment from Microsoft into the Stockholm tech community and startup scene to host workshops such as this, to educate and provide skills to the general public, as well as we are a space for hosting other meetup groups. So if you ever want to give a talk or present something, you can talk to one of my colleagues, Erica, and we can book you in, and you can give a talk about whatever you want as far as technology and what's up. We actually next meetup we'll have is a community or external meetup, the Stockholm Machine Learning Club, but we're also doing a partnership with a content kind of show we do at Microsoft called Bit of AI. So that'll be happening next week. I really love AI, as you'll probably see in this presentation. So yeah, if you're interested in that, it's going to be two people sort of presenting stuff that they have actually worked on in the field or passionate about, and then we'll also have like a panel, people to give like how they got started in AI, what they're doing now, and a little bit about like what life in AI is now. But yeah, thanks for joining. So today we're going to be talking about starting your AI builder's journey. It, so you might have, if you've come here, you might have said this to yourself, like, I want to start building with AI, or maybe you started building with AI and then got frustrated and not don't want to start building with AI anymore, or maybe you come to all our events, which we love you for anyways, so that's great. But really, this is going to be kind of answering that question of if you want to get started, where do you start? And most people go to a search engine, so maybe you use Bing, hopefully, and you've probably typed in something like building with AI or AI tools, AI platforms, or something, and you probably got hit with a lot of results. So this right here is the 2021 landscape of like ML, AI, and machine learning tools, platforms, languages that someone could use to get actually started with AI. And as you can see, there's quite a lot of these, and I'm glad I'm on the big screen here so you can actually see, at least I can see some of these logos here. But it's quite a congested field, I guess. There's lots of choice out there. So how do you actually, especially if you've never worked with any of these things, it takes time, maybe it takes money to try these things out. So how do you like make the best decisions on what your use case is, your skill sets, and your experience, and how do you determine what to actually use? So, and even at Microsoft, we're probably not the best, but I think we're definitely getting better on kind of consolidating or bringing these products together. So we have kind of four main categories in the Azure world for cognitive search, cognitive services that does some of the computer vision stuff, which I'll explain later, machine learning, as well as the bot services, things like chatbots and stuff like that. But that would be kind of doing a disservice because also we acquired companies or integrated AI into other products. So we do also have other products out there that might be also if you're just starting out, quite confused. So we have Lobe, which is like a no code AI platform. We have AI Builder, which coincidentally is not about this talk. So we're not going to specifically talk about this product, but it's actually embedded in our Power platform. And then we also have things like virtual agents, which again is also gearing towards the conversational AI and chatbots. So I'll be your tour guide through this journey today. So my official title is I'm a cloud advocate. I specialize in the AI space. So I've been kind of working for the past 3.5, 4 years in AI and data science. I've in past positions kind of helped AI startups and builders or people just getting started on navigating this space. From they have saying, I want to start with AI, but have no idea where to go. And I'm also the organizer of the Stockholm Machine Learning Club, which is again kind of geared towards advancing the education of um, AI and machine learning here in Stockholm. And I put ex podcaster because I saw it was really popular. Put podcaster on your bio here, but I don't think anyone's bragged about being an ex podcaster. So I used to host a podcast called The Maker Show, which was specifically talking about interviewing people who have built startups with using AI or AI purpose-built startups. And so I've got some experience, at least, is talking about like how and the actual real use cases you can get started with. So we have a few different learning goals for this talk as well as the next talk, which is kind of like the sequel to this. So first, I would love to just that you feel that you can navigate the world of AI tools with some confidence. so you know what the tool does or kind of what the use case gets addressed to. And again, also if you should use this tool or not. I won't be sponsoring any tools in today's talk, so it won't be like a sales pitch on Azure. But this is also going to just help you get an understanding of, when you start looking at these things, which ones make the most sense for you. I hope you fall in love, if you're not already in love, with what is possible with AI. I know that's a big sell and a big goal, but I was probably sitting in your seats about 3.5 years ago, and a very similar talk, and now I'm up here talking about it. So things kind of move very quickly in the world of AI, especially if you're interested. You start building things and get very interested in it. I hope then you also have a solid understanding of the benefits of real AI use cases. So this is, I'll talk a bit more about what an AI builder is or what I think it is, but this is really focused on building something. So we won't be talking today about like, the layers of a neural network or different statistical models that you can apply, but like how can you actually get started building something and apply this to some real use cases? And then I hope at the very end to inspire you on, really what's possible, and that I have a really secret interest that you come to the next workshop as well. So hopefully I can give you some examples that will inspire you to start working on yourself on your own projects. But how did we get here? Like, why do we have so many tools now? Why are they, so hard to kind of navigate? And I guess if you look at kind of a brief AI history, and I won't go into too much detail, most people say the birth of AI happened in 1956. So a group of men, because unfortunately that's what went down in 1956, all came around in this conference and they came up with this term, artificial intelligence, to apply to computers that can sort of compute on their own or make some sort of intelligent answer. And then we had from 56 to the 74, like the golden years of AI, where we had a lot of different products that were made. So we had like Eliza, which was one of the first chatbots, Student, which was like a AI that could solve not only algebra problems, but algebra word problems. So it could understand language and then also provide some sort of computation based on that. And then, unfortunately, and you'll probably see in the theme here, we had an AI winter, and what AI winter really means is like, okay, AI didn't really fulfill most of the promises, all the promises, for example, or funding got shifted. So normally, whenever the money leaves, then the investment in growing AI goes as well, because especially in the 70s, AI, even in today, is a very sometimes expensive venture. So once the research and the funding went, most people started to focus on other things. But then it started picking up again in the 80s with the term expert systems. And expert systems isn't necessarily artificial intelligence as we think of it as today, but more so of a machine kind of making decisions based on rules. So this is like if you're a coder, like if and or if else statements, and really just trying to make decisions based on some predefined logic. So it was interesting that these machines could do decision making or provide some sort of prediction based on these rules, but it wasn't necessarily exactly what we probably talk about AI today. And then again, the funding went, people got uninterested. It wasn't as cool as we thought it was, maybe. So we had a second AI winter. And then from the like early 90s to 2011, I was going to say like currently, but that's nearly 11 years ago, so that's crazy now. AI started fulfilling their promises, right? So this is like almost the science fiction promises that we expect AI to do. So we had Deep Blue, who beat the reigning chess champion. We had DARPA, which was like a competition for autonomous vehicles. So that was also solved or won. And then we also had Watson, which is an IBM product, win the Jeopardy game, which is, if you don't know Jeopardy, it's like an American TV show that people leave on in the background, and some people really love it, but it's like a trivia show. So again, AI started to really look like what we thought it was going to be in the science fiction world. And then right from 2011 to now, we started expanding to deep learning with neural networks. And neural networks is really, again, kind of how we sort of function as humans, or how we perceive the world. And it's built on neural networks to be able to decide what, how we see or how we speak, much in the same way, and interpret language. So kind of how we, once you build like a neural network, uh, model, you can kind of release it out into the public and it can be reused. So we had some popular ones like ResNet, BERT, which is a language model, and then probably more recently GPT-3. So if you've ever seen anything in AI, you've probably heard of that. And what we discovered was that these are all reusable. So let's just make this accessible to other people. And we built a whole bunch of tools on top of these models. So that's where we kind of how we ended up here was a lot of people said, okay, well, we don't need to necessarily always innovate or build bigger models or newer models or more efficient models, which we still do, but let's just add some tools and make it easy for more people to use and enterprises and companies. So that's kind of how we got into that giant image that you saw in the earlier presentation or the earlier slide. But what is an AI builder? And to be honest, I kind of made this term up. So I don't know. Maybe bear with me. Maybe you agree. But I've noticed is since we have so many tools, there is a new sort of space for people who want to work with AI that don't necessarily need again a PhD or some sort of statistical background to actually get started. And you don't even need to know how some of these things work. I mean, it's great and beneficial, but you don't need to know like, well, okay, this layer of this neural network does X to get up and running, really. Again, this is kind of how I see the world. So we have AI in research, which is kind of tied to the academic or private sector. So normally someone is very specialized in like computer vision or even ethics, and their main output is to publish papers. So you'll see when you start maybe looking at AI, you'll see a whole bunch of papers that are published, and I think they're a really great resource to understand what's going on. But again, you don't necessarily need to read papers to build something with AI. And then we have AI in enterprise. So this is like uh, most of the time people with titles like data scientists, machine learning engineers, they normally have a large data set that like is easily accessible or built pre-built. So meaning like, oh, we want to make you work some on our sales numbers, and they have like this giant sales database that like the company's been collecting since the 80s, and they can start building models on that. And not everyone has access to that, and it's not necessarily free, but normally, again, the output is they're trying to solve some sort of specific business problem, make some sort of efficiency there, and then go on to, again, produce something for the business. But where I see a growing space for is AI builders. So this could be anyone. Normally it could be someone solo, a startup, or just someone that does like a hobby weekend project. Normally, you can sort of build your own data set. There's like tons of free data sets that you can get, especially living here in Stockholm. There's quite a lot of city data. And then you're probably solving some sort of specific problem, either for a customer or your own problem, and how to actually get building using AI to make that efficient. But what can I do with AI? And I think that's really an important question because when I have had early conversations with other, startups or people that want to get working with AI, it kind of sounds like a black box. I want the AI to do this, and that doesn't really help anyone if you need to do this yourself, and you need to find different tools there because then you don't know how to segment or what AI capabilities are out there. So I really like this quote. I'm not going to read the entire quote to you, but it's really that imagine if like AI or machine learning is completely fake, and there's an island of people that are going to be able to complete tasks really quickly, and you just need to give them that task, and they will be able to present results quickly. Whether that's okay, I want to read all these emails and tell me what language it is in or what topic is this image. So if you just imagine that largely most of the AI functions that it can specialize in kind of relates to making these repetitive processes more efficient. But how does it do that? And this is kind of really like what are the different elements of AI and what the different approaches are. So I've kind of divided the world into these six boxes. So we have the traditional machine learning, which is kind of based on a lot of statistical models, computer vision, which, as it says, how you can kind of visually using AI, or whether it's doing object detection or classifying things in image. We have natural language processing, NLP, which is again how a machine can kind of understand and interpret language. We have knowledge mining, which is probably more geared towards the enterprise, but like how does the AI make sense of large amounts of data within an enterprise? We have anomaly detection, which is okay, we go through some sort of process. How do we detect these things? And then generative models, which I think has probably been the most exciting space so far. And this is where you get things like GPT-3. So on the machine learning model side, So we have kind of classification, which is I guess, classic example is kind of like spam or not spam. Is this person? Was working on a project once and was like, also it's a popular one in data science about Titanic and like, is someone going to survive the Titanic or not? And you take basic inputs, and the machine or the algorithm sort of learns based on those things and then finds when you find a new point what is in relation to that. One of my, I guess, favorite is K or nearest neighbors, which is you basically are defining or plotting different points, and then you get a new point on the plot, and which one is its nearest, because then that's probably very similar to that. So people do this stuff with like customer segmentation or finding if you're going to like you know uh, cancel your Netflix subscription or something, which is unfortunate for that company. So those are the kind of classification issues. We have regression, which is also making sort of predictions based on things. So the less interesting one, but also very popular use case is around predicting sales. But I was talking also, we had an interesting case where you were trying to predict robot maintenance. So, repairing a robot is expensive. So if we can take different inputs or different gauges and say, oh, the robot might fail tomorrow or 6 months, this saves a lot of time and a lot of money for companies or for yourself. So using a regression model, we can kind of make predictions based on these inputs, and you have a feature or a prediction based on the model. And then we have clustering, which is again how we sort of bring different data points together and if they relate in some type of way. So I've done a work on a project where we're trying to find like the best neighborhood in Stockholm, which may be super subjective to some people, but we use a lot of data around like Foursquare and different ratings around the restaurants that they had there, different pricing for Airbnb data, so like how much things cost for staying there, and then we clustered each neighborhood so that this is like, okay, these are different tiers of neighborhoods essentially based on all this data, and we could say, okay, these are the top 5 neighborhoods because of that. So the model kind of understands we're trying to find different relationships in there. And then I think the bigger space is, and the most exciting is in deep learning. So this is where we're also working with, instead of doing statistics, we're working with neural networks and how that works. So the first kind of big space in deep learning is computer vision. So we can do image classification, so understanding what actually these images are about. In this case, we're actually predicting what's in the image or kind of making a prediction on how the model feels. So it can see here that, okay, there's scaffolding, so these little rails, the guardrail, you can see there, and then there's water. And it's not saying necessarily saying that like the image is 60%, but it's like 60% confidence that there's water here. There's object detection, which probably the biggest use case is in autonomous vehicles. So an autonomous vehicle can kind of detect, oh, here's another car, here's a child, automatic emergency brake, things like this. And it's essentially boxing around these things in an image. So we're detecting which objects they are and if they're of interest. This way right here has a nice little output of where it's like each square has a confidence or a prediction level on how well the model thinks there. So this one's definitely a bolt, but maybe an image like this or a box like that, it's not so well because lighting. So again, the model can kind of give you those outputs. And then we have semantic segmentation, which is essentially going in and segmenting these images. So I can find where the train is, or where the dog is, or where this lady doing some weird thing is doing, all within the image. And again, that's could be useful for certain use cases where you need to, like, to say, satellite imaging, where you want to find where the crops are. So big use cases around climate change. So you can look at satellite images and say, okay, the crops from this year are this big because the model said so. And then, 10 years from now, the crop size has decreased. And you can actually physically see or, visually see based on the model where the crops are growing. Exactly. Yeah. So this is on a pixel level, and this is like a little box. And another probably follow up question is like, what's the use case for either of those? And I mean, in this case, it's probably more important. It's important if, like, for instance, I don't know if you can see it, but like a person, for instance, where maybe even like in autonomous vehicles, you probably want to like not get that close to a kid anyways. So like pixelating or getting as close to the object is not that important. Mm. Yeah, so it's just on a different level for that stuff. And like I've seen another use case where on object detection where we do stuff with drones and like forest fires. So like drones can fly around and see forest fires, and then they detect smoke and flames using object detection. Where it doesn't really matter on the pixel level where the fire is if there is a fire. So kind of like yeah. mm, yeah. Yeah, you could. Yeah, yeah. So this is a lot about yeah, I guess you can cement like if you want to see there actually like people close to that fire or something like that, you probably could. But also again, you could probably just say person an object detection because you probably want to just get them to evacuate or something. Uh cool. So then we have NLP, natural language processing. So with some of the use cases around sentiment analysis or sentimental analysis. I'm not sure which one is correct, but this is again like taking some sort of text and understanding what is being said or what are the feelings behind that. So one of the bigger use cases, I guess, is around moderation. On any sort of social media platform, let's say Meta or Facebook, probably uses some sort of semantic detection on your comments so they can know if you're saying anything hateful or harsh, and then they probably have like a human to moderate them that further. And then we have speech recognition, so just understanding what is said, so you can, if I were we're streaming this, and we wanted to have a transcript, that's all speech recognition there. And then we have the conversational AI, so it's not only taking what's being said, but then making some sort of response based on maybe the database or what the AI feels is kind of completing the goal of the user. And then we have knowledge mining. So this one, I think, from an AI builder perspective, again, running with my own definition of what AI builders are, probably not as used, largely because this it requires lots of data. So either structured or unstructured data. So like as a company, you're constantly producing images and CSVs and documents, and you probably have that in a OneDrive, of course, and then you want to like find some sort of meaning there either by searching it or finding some relationships to them. So you can use knowledge mining to essentially use different types of models, so speech, vision, and search, to kind of parse to there so that you can get insights. And as a user, you don't have to like control F to find things. You can actually like easily find information in your business. So that's been a big use case around the enterprise side, because they produce naturally so much data and people need to find information as quickly as possible. And then we have anomaly detection. So this is probably the most simplest definition of what anomaly detection is. You have some sort of value, whatever you're measuring, and then you have the time of it going on. So one of the use cases around this big one is like manufacturing. So you have a machine that's like just every day it does that, and then one day it goes. That's probably because it's broken, or you never know. What the anomaly detection does is doing some sort of sound analysis, and then you have these sort of boundaries where, okay, if this is a really loud noise or a really loud something, then we can detect that and essentially say, okay, someone should check the machine. So it's basing that on different factors, whatever you have in regards to your use case. And then my favorites, the generative models. So we have adversarial networks. And basically, adversarial networks are when you have two neural networks competing against each other that says, like, okay, this is a picture I created. So they're actually creating images. And then, okay, is this actually a human or this is not a human? So I have this picture of this woman. I'm sure, like, who is this woman, or did you get her express permission to be in the slideshow? And the answer is she's completely fake. She's not a human at all. So an actual AI model generated this. So there's a site called thispersondoesnotexist.com. Highly recommend you go to it because it just continues to generate these types of images. And what is happening is there's one neural network saying, I'm going to make this image of a human. and then another neural network saying that doesn't look like a human, that doesn't look like a human, that doesn't look like a human, and then the other neural network goes in and improves their performance until it tricks the determinate the judge essentially neural network to say, oh, that does look like a human, and then you get something like this, and you can constantly run these things. So there's probably good use cases for this, bad use cases, evil use cases. I don't know, what have you. I'll leave it up to you to decide what to do. But yeah, super interesting space and always kind of growing. And then we have two bigger ones coming up now from OpenAI. And OpenAI is like a kind of AI for good nonprofit, but they do a lot of AI research. And then they release these first, not publicly, because they are super afraid of people misusing them, and then publicly. So first one is GPT-3, and that uses a combination of things. So it actually just uses NLP to understand what the text is reading, like is pineapple a good pizza and topping? And as I do agree, pineapple is a good pizza topping. So it can actually do some question and answers. It can generate text. So if you give it a prompt and say, "Tell me a story about today," or like, "Oh, today was a good day," it can like continue to tell your story and saying, "Today was a good day because I was productive at work." So it actually uses I forget like a billion different factors or features within the model, and it was used on large amounts of data. First, Reddit data. So if you ever used Reddit, so it kind of understands natural language as the idea as we speak, and then also using the models to generate these sorts of texts. So interesting use cases. I'll also explain later. And then we have this newer one that came out maybe last year, I guess. But now you probably, if you're on Twitter and follow AI people, you'll probably get your feed filled with these sorts of things. So Dolly 2 is a model where you can actually type in stuff like, I want a realistic photo of an oversized gorilla bear posing for his grad photo on campus, which is super specific, right? And boom, the model produces exactly that. And it's using, again, NLP to kind of understand what's being said there, and then image embeddings, which is ways to like represent those images in numbers, and essentially making these calls where how this should be generated. So it understands the text, and it takes text and the images that it's been trained on and combines those two because it understands the relationship between them. It's kind of the simple definition there. Yeah. Exactly. Yeah. So this it can because one of the other use cases is around like e-commerce as well. So let's say you want to build out like a whole e-commerce catalog and you don't like actually have products. So maybe you're a scammer or something, but like you want to like just fill it out with all these new products. You can use an adversarial network to fill those things out. So this is a great way to building synthetic or 3D data. And we had a conversation, but just to clear everyone else. So one of the problems, especially in certain industries, is like how do we get data either for regulation or legal reasons you can't get data, or just you just don't have much access to data. One way you can actually do that is building it through fake data or 3D modeling, and the model can actually learn on that still and learn from that so that it can actually recognize that in the real world. So yeah, it's just a very interesting space, I think. So how can I get started actually building with AI? So one of the things I think this is like the number one step for, and I said step number one, and I think it is, and also the number one step to AI success is actually like framing the problem, like how AI can solve this. So a lot of times I've had conversations with people, and they say, "Yeah, I would like the AI to do this," and it isn't necessarily requiring AI. So I always say you should ask, like, "Can this be solved in another way?" And this is from a person who loves AI, so you should trust me on this. Like, I don't think, not that it's necessarily because it's the cost or it's complex, but sometimes you could be quicker to actually developing something when you use other methods. So one of the bigger ones is around just basic automation. So I had a project I was working on, and they wanted to have like an AI that takes a job description and then just posts it everywhere. And they thought like AI could do that. So like, oh, I fill in a job description and I go to every single job board and it gets posted there. you don't need AI to do that at all. Like that's just basic automation. You can sort of use there's different tools out there where basically it's just copy and paste and post. That's like 3 clicks. So it's not necessarily AI that needs to be done there. So always think like, can I solve this with something else? Um, Also, then and I think you get better results that way if you still need to answer yes, because then you can really invest your time in working with AI. The next question is like, how will these predictions be used? So AI again is always going to be providing a prediction. It's not ever 100%. So sometimes people put predictions where they're the driver. So they okay, AI predicts this is spam or whatever, and then okay, we're going to delete all these emails. Like that's AI as in the driver's seat, but maybe AI is just driving or helping driving the process. So AI says, okay, this is all spam, and it puts it in the spam folder for you to delete. So it depends on the consequences on how AI is sort of being framed and how you're going to use your predictions, because it's sort of important, when we go into the deeper depths of like what are the correct results and how is the model trained. So that's something to always think about. And then lastly, it's like, what will the world look like after this? How much improvement do I want? I've talked to people and they're like, oh, right now, if a human does it, it's like 30% correct. And what would you like if the AI does it? 31%. It's like that's it. Like, okay, well then this is going to be great for an AI use case. I'm sure AI will probably predict the results. But yeah, maybe if you're looking for a pure perfection, um, yeah, AI is probably not going to necessarily always be the best use case. Or you put AI in the process so that you can make those improvements with having a human kind of working with AI or kind of coordinating with that. So these are the kind of things framing the problem. And as a lead up to the next session, this is where we'll sort of start building an AI project. But I'll leave you with some inspiration. Like I said, I hope you come next time. So I want to give you some ideas on what others have done as solo people, or people non PhD have been studying AI themselves. So the first one, I don't know if has anyone done any 3D printing here? Sort of, kind of, like half 3D printing. Okay, gotcha. Well, I've never done 3D printing, and I didn't know it was like a dangerous hobby. I would classify it as, because these machines, they get super hot, and they actually require um, you to watch the machines most of the time. Because let's say there's an error in the machine, and you let your machine go, and you leave home or something, they could catch on fire and burn your house down, which is probably not your goal. So this person, her name is Lee. Sorry, I didn't include names here. She built a company called Print Nanny by herself, and it essentially uses computer vision to monitor a 3D printer. So there's certain things I'll play this video. It's like super fast, but that's like literally how it works. But it's basically using object detection here. So it's building the print of what is happening, and they have this thing called spaghetti. As you can see, it looks like spaghetti. And what it essentially that is a problem with the printer or the model, and the machine needs to be shut off. Doesn't need to continue on. So using computer vision, again, using the boxes because it's no reason to segment it. It's basically showing, okay, we have spaghetti coming here with 80%, so we should shut off the machine. Again, it saves time for people in this hobby. They don't have to monitor the 3D printer. It saves your house from burning down. So ultimately, a net good for 3D printers and AI. Cool. And then another founder, his name is Ramsuri. He actually built a company called QuestGen, and essentially what that does is it can take, like, let's say a Wikipedia article, and and generate questions and quizzes based on that Wikipedia article using NLP. And it's primarily just a multiple choice. So you can imagine if you are a student that wants to study on something, or a teacher that wants to generate quizzes and maybe you make your job easier. I don't know. You can easily just take an article, run it through this model, and you'll get multiple choice questions based on that article. And it's also making predictions that are obviously feasible, right? It's not, A is the correct answer and B are just some B and C and D are just obviously wrong answers. So it does that using NLP and understanding relationships. So it can take the text and then also look at what are similar things, like who was the first president of the United States. It would list the first president, obviously it's the correct answer, but then also pull in presidents' names, not just banana or something. And then this was, I think, one of the very interesting use cases around GPT-3. So this founder was Robbie. He's founded a company called Calendar AI. And this is using GPT-3 to create better introductions into emails and LinkedIn messages. So if anyone's worked in sales, like the intro is the number one thing to nail to get any sort of business growth. And what the interesting is for me, I think it's like so GPT-3 was trained in 2007, 2008. So it doesn't it's not necessarily old data, but what happens and what he has incorporated here is like let's say you have a prospect or a company you want to sell to, it actually pulls in data based on that industry. So let's say I'm in let's say I work for Microsoft, it actually pulls in all the latest publications, all the latest news about Microsoft, and it incorporates that into the intro of the email. So it could say something like, "Oh yeah, it's crazy that you have Microsoft Build next week. Are you excited about that? And we should meet for a coffee." Obviously, I haven't worked in sales in a while, so it's probably the worst introduction. But it does all of that, and it's completely AI generated, and then it kind of automates some of the process around, um, like picking the time because that's also another friction point. But again, completely AI generated introductions and using GPT-3 as well as new data to provide that. So again, this is like taking the title, the industry, the company type that it is, and then is essentially going in and making specialized, tailored messages, which is the key thing for sales. But yeah, again, all these people are solo founders, people like yourselves, maybe. No need to, have this degree in machine learning or AI to get started and working on something. So the next session, like I said, I have an interest in you coming to this. So we're actually going to start building your first AI project. So we'll talk about finding data, choosing different models, kind of applying them to the use cases, choosing the right tool to train the model. So I think just discussing it with everyone, I have an idea of what we might go with, and then actually kind of like what we kind of trying to deploy into the real world or build a startup or a company like you just saw in those last three examples. But for the next time, as a homework, if you want, is there's a couple of different Learn modules within Microsoft. So we have Microsoft Learn, which is a great resource for just anything Microsoft based. But we have two ones I think are really tied to this presentation. Is one is about choosing the best AI service, which you can kind of navigate some of the stuff I talked about, defining the problem. How does those different use cases or applications of AI fit into that? And then the other one is AI fundamentals. So if you've never worked with AI before, or I mean, if you want like a quick refresher on some of the stuff that we talked about here, these are two great Learn modules for you to get started on, and it will ultimately prepare you for the next session as well. But yeah, thanks so much. Again, appreciated the questions, and yeah, well, I'm happy to stick around and also chat about some of the use cases or where you are on your AI journey and where I can sort of point you to.